So today's lecture, air compressor. What is meant by compressor? Compresses the air. How? Reduce the volume. Without reducing volume also we can compress the air. Increasing the pressure. Okay. So how normally air compressors works? Air compressors are work consuming devices or work producing devices? Air compressor work consuming devices, right? So work consuming device, what type of work it will consume? We have two type of devices. Amalia, for example, if you take a system, either you will give work in, or it will produce the work. Yes or no? Or sometimes you give the heat input, or it will produce heat output. Speaking thermodynamically. Tell me, the compressor, either we are giving the work or it produces the work. Produce the work. What type of work you get? What is meant by work? There should be any change in boundary. Clear? Or it has to produce shaft work. Something it has to do, right? Tell me, either it's a work consuming device or work producing device? Work consuming device. We do work on the system. What type of work? What work? Electrical work will give, right? We use some motor. This shaft will be connected to the system. We will give electrical work. Any compressor you take, what we have? We will be having motor. Without motor, none of compressors works properly. Got it? So we give electrical work input. Refrigerator, work consuming device, because we switch on the refrigerator. There also we have compressor. Clear? Wherever we have work consuming device, maximum 99.99% we use electrical work only. Clear? Now tell me, either are we giving a heat to the system or it produces a heat? Compressor. Are you giving any heat to the compressor? No. Just switching on. Upon I am not giving. Compressor will produce a heat or not? It will produce a heat. Okay, so no work output, only work input. It produce heat also. Then what is the purpose of compressor? What is the purpose of converter? To compress the air, to increase the pressure of air or any medium by electrical to mechanical to pressure energy. Got it? We supply electrical energy to the motor, where the motor convert electrical energy to the mechanical shaft output, where it runs any compressor, so that pressure will increase. Got it? This is how the compressor will work. Got it? Then what do you mean by air? What is meant by air? The working medium is a air in our syllabus. The working medium is a air. We are going to study about completely air compressor. Since it's compressed air, it is called as a air compressor. Got it? Write down the definition. Compressor is a mechanical device which increase pressure of any gas. Okay, now write down classification of air compressor. Classification of air compressor. There are so many types of air compressor, but generally the air compressor are classified into two major categories. One is positive displacement air compressor. Positive displacement. I put only compressor, okay? I am not writing air compressor. The other one, non-positive or dynamic compressor. Got it? So first we need to know what is meant by positive displacement compressor, what is meant by non-positive displacement compressor. That's very important. Okay, here we have two type of compressor. Let's take, this is reciprocating air compressor similar to our IC engines. We have seen, right? Here the air is compressed by movement of the piston. The piston will move. What happens? When piston move upwards, the volume of the cylinder decreases. When piston move downwards, increases. There is a change in boundary is there, right? There is a change in boundary is there inside in order to compress the air. But here what happens? The air will take this side, it will compress to the narrow space. It will compress to the narrow space. So this is axial flow compressor. Do we have any change in boundary here? Due to the movement of the blade? No change in boundary. So if there is no change in boundary, if you compress the air, that is called non-positive displacement air compressor. Non-positive displacement air compressor. See, again I repeat, here the air will be compressed through changing boundary of the system. Changing boundary of the system. When piston moves downwards, the volume increases. When piston moves upwards, the volume decreases. So based on that, the air will be compressed. But here, just the blades will rotate. The impellers will rotate so that the air will be compressed to the narrow area. Here there is no change in boundary. If there is a change in boundary, if you compress the air, that is called positive displacement air compressor. If there is no change in boundary, if you compress the air, that one is called non-positive displacement compressor or dynamic compressor. This is the basic classifications of air compressor. Got it? So which one has high effect, sir? Which one will be good? Both are good only, but based on the application, you have to choose which one we have to prefer. Clear? How to prefer, sir? How do I know whether I can go for this compressor or this compressor? If you see, in partial displacement air compressor, we have so many types again. We have so many types. We have reciprocating, we have a rotary. I'll write all those things, okay? So first we will see the difference between these two. Due to change in boundary, the pressure developed in this compressor is very high. Number one, the pressure developed in this compressor very high. Since there is no change in boundary, the pressure developed in this compressor is very low. Right? Here, second one, here one stroke section, the other stroke delivery, compression delivery. Here, not like that, continuously delivery. Continuous delivery. So here, intermittent delivery. Here, continuous delivery. Correct. Since it's an intermittent delivery, what about the mass flow rate? Mass of air delivered will be high or low? Volume of air delivered, mass of air delivered low. Which means either m dot or v dot. Mass flow rate or volume flow rate, our wish, okay? It will be very low here since intermittent. But here, mass flow rate or volume flow rate will be high. These are the basic classifications of positive displacement air compressor, non-positive displacement air compressor. For example, we have the application where you need only small quantity of air but at a high pressure. Small quantity of air at high pressure. Which compressor will you choose? positive displacement air compressor, where you need only medium pressure, but you need large amount of air. Which one will you use? Non-positive displacement air compressor. Very simple. So based on that, we will segregate the either we have to go for positive displacement air compressor or non-positive displacement air compressor. Do you have any doubts here? Do you have any doubt? Shall I erase these two diagrams because we have to write much? Shall I erase? Okay. I will erase these two diagrams. Okay. Now I come to the point. In non-positive displacement air compressor, we have only two types. One is axial flow compressor. The other one centrifugal compressor. Centrifugal both works under no change in boundary. No change in boundary. Again, this positive displacement air compressor is divided into two categories. One is reciprocating compressor. The other one rotary compressor. Rotary compressor. Got it? Again, the reciprocating compressor, we have so many stages. We call single stage, multi-stage. Clear? Like that, it keep on goes. It keep on goes. If you come rotary, it is very quite. We have so many vane compressor, screw compressor, hermetic compressor. All are works under rotary. All are works under rotary. These are the example of few only. Vane, screw, hermetic. Only few type of air compressors. Got it? Rotary air compressors. These are reciprocating air compressors. So in our syllabus, we have only reciprocating air compressor. Along with that, a small theory of axial flow and centrifugal air compressor. But these both are theory. We are not going to discuss analytically. But here, centrifugal air compressor will be discussed analytically. Got it? Copy it. Make it fast. I will erase this.